Hey, ladies and gentlemen, welcome to our second day of notes for this unit. So today, to start off with, we're going to talk about dependent events. Okay, so dependent events are the result of when the first event impacts the second event. Okay, so yesterday, they two didn't really affect each other. We could do one and we could do the other, and it didn't change our total. Well, today, things are going to change around a little bit. So for example, a dependent event is if we want to find the probability of drawing an ace and then a 4. So I'm going to first calculate the probability of drawing an ace. And then once I have that ace card, I'm going to take it out. Okay, so now my total's dropped. Okay, so that's what we're going to be looking at today is the two events are affecting each other. So if we're looking at the difference between the two, independent is when they do not affect each other, and dependent is when they do. So tomorrow we're going to have to decide if the events are affecting each other. But for today, we're just going to focus primarily on dependent events. So that's where the two events do affect each other. So let's take a look at what one of those examples might be. Again, if you didn't have time to write that chart down, go ahead, rewind a little bit, pause it, because I'm going to talk faster than you can write. And notice that little blurb on there again. Remember that and means you need to multiply. Okay, and means you need to multiply. Let's take a look at number 1. 3 cards are drawn from a standard deck of cards without replacement. So this without replacement right here is huge. Okay, this without replacement is immediately going to tell you that you are doing an independent or a dependent event, I'm sorry. You're doing a dependent event when it says without replacement. Okay, so then we know that the two are going to affect each other. So 3 cards are drawn for standard deck. Find the probability of drawing a heart. So the probability of drawing a heart, well, first of all, we know there's 52, that's hard to see. There's 52 total cards. Okay, now we have to figure out how many of them are hearts. Well, there's 4 suits in a deck. Okay, so then we have to figure out how many hearts there are. Well, if there's 4 suits in a deck, divide 52 by 4, and we get 13. So there's 13 hearts in a deck. So now we're going to draw, and we're going to assume that when we drew out a heart. So I'm going to take that heart, and I'm going to set it aside. So now I have one less card in my deck because I took that card out, and I set it aside. Okay, and I also assumed that that card that I pulled out was a heart. So now I only have 12 hearts left in the deck. Okay, let's move on to the next one. Let's take a look at the probability now of drawing a spade. Well, I've taken out one heart, I set it aside. I've taken out another heart, and I set it aside. Okay, so now my total is down to 50 because I've taken 2 cards out of my deck. But as far as spades go, I still have 3. Or sorry, I still have 13. Okay, because I took out 2 hearts, so my total went down 2, but I assumed that I didn't pull out any of those spades. Okay, so now I'm going to go ahead and I'm going to first multiply the numerator. So this times this times this, and that's going to give me 2,028. And then I'm going to do this times this times this, and then I get 132,600. Divide those out, and I get 0.015. Okay, so that's the probability of that exact situation happening. Let's take a look at another example. So for number 2, there are 3 miniature chocolate bars and 5 peanut butter cups in a candy dish. Liz chooses 2 of them at random to eat. So we're going to assume for this one that when we're drawing out candy, we are going to be eating them. Okay, so if she chooses them at random to eat, that means we're going to eat both. So that means my total is going to go down, and it's a dependent event. Okay, so if there are 3 miniature chocolate bars and 5 peanut butter cups, that gives us 8 total. So we have 8 for our total. So when we start off with, we have 8 candies in the jar. Okay, and then we're going to choose 2 of them random. We want to find the probability that she chooses 2 miniature chocolate bars. When we know there's 3 miniature chocolate bars, so the probability at first of drawing a miniature chocolate bar is 3 out of 8. So I'm going to take out that miniature chocolate bar. And who takes out a miniature chocolate bar and doesn't eat it? I certainly don't. I'm going to eat it. So when I eat it, my total is going to go down 1. Okay, so now I have 1 less candy in the bag. And because I ate one of the miniature chocolate bars, I also have 1 less miniature chocolate bar in the bowl, so then that's also going to go down. So now here we've set up our probabilities. So we're going to multiply the numerator and then multiply the denominator. So 3 times 2 is going to give us 6. 8 times 7 gives us 56. you can reduce that fraction to be 3 over 28 or 0.107. Okay, you can leave it as a reduced fraction or you can write it as a decimal. I don't really care. It's up to you and what you're comfortable with. Let's take a look at number 3. In the state lottery game, each of the 3 cages contains 10 number balls. The balls are labeled with the digits 0 through 9. What is the probability the first 2 balls drawn will be odd and the third will be prime? Okay, so let's start this off. Okay, so we have 10 digits. If you could write them all out. Okay, we don't want to write 10 as a digit, okay, but there are 10 digits. So we want to figure out the probability the first 2 balls drawn will be a 10, or will be an odd, sorry. So first of all, there's 10 digits, and then we want to look. We have 1, 2, 3, 4, 5. We have 5 odd numbers out of our 10 balls in there. So we have 10 or 5 out of 10. So when you're doing the lottery, look at it like bingo. When I draw that number out, I'm not going to put it back in. Okay, so I'm going to set that ball aside. So now I have 1 less in there. So I have a total of 9 balls in the cage. All right, and I know I'm going to assume that I've already pulled out an odd ball and set it aside. So here it says the first 2 balls need to be odd. Okay, so that's sometimes hard to notice, is that we're actually looking for the first 2 being odd. So, okay, our total's down, and I've already also drawn out an odd, so then I only have 4 odds left. Okay, so again, we'll keep moving on down. Last but not least, it wants that the third will be prime. Okay, so we want that the third is going to be prime. So let's just kind of write that out here. Okay, so now I only have 8 balls left in my cage. Okay, and I want to figure out what's the probability that's going to be prime. So prime numbers, I have 2, 5, 7. Okay, so I only have, oops, and 3. So I have 4 options of it being prime. So now we're going to go ahead and we're going to multiply all of those together. So we have 5 times 4 times 4. And that's going to give you 80. And then 10 times 9 times 8, that's going to give you 720. That fraction reduces to 1/9. And you get a probability of 0.11. Now, this is a more difficult example than I'm going to expect from you, but it's kind of good to kind of explore that stuff a little bit as you're learning this stuff. Let's take a look at some problems that I think you guys, or I would expect out of you, like on a quiz or on your homework and so forth. Find the probability of drawing 3 cards of the same suit without replacement. Okay, well, we're not going to replace it. So again, this without replacement tells me that I have a dependent event, which means the 2 of them are going to affect each other. So let's just pick a suit. I'm just going to go with diamonds. Okay, I'm going to pick all my suits are going to be diamonds. Well, we know that for any given suit, there's 13 cards of each suit out of the 52 total cards. So then if I want them all to be the same suit, I want to keep picking up diamonds. So that's what I'm going to keep doing. So then here I'm going to do a diamond. But now if I've taken out 1 diamond and I've set it aside, my total has gone down, as well as I've also lost 1 of my diamonds. Okay, I've also lost 1 of my diamonds. Now, next, I want to draw out another card. So now I've set 2 cards aside. So my total is now down to 51. And I want to look at my diamond. There we go. That's a terrible diamond. Don't judge me. Okay, so now I've set aside 2 diamonds and also 2 cards. So my diamonds have gone down as well as my total has gone down. So the first thing we're going to do is multiply across the top. And I get 1,716. Then I'm going to multiply across the bottom. That fraction reduces to 11 over 850. And I get 0.013. So that's the decimal. So there's about a 1.3% chance of me drawing 3 cards in a row from the same suit. Okay, let's take a look at number 5. I'm going to get it set up and then I'm going to have you guys multiply it out. Miss Humbert is handing out Dum Dum suckers. Okay, now everybody has their favorite kind. Everybody always asks me, well, let's calculate the probability of you getting the one you want. You and your friend Shirley like strawberry. Miss Humbert has 3 strawberry and 7 other kinds. So 3 strawberry and 7 other kinds means that we have 10 total possibilities. So I have 10 in my hand. Okay, so let's find the probability that you and Shirley both get a strawberry sucker. So let's say I'm walking around the classroom. I come to you first. So we want to find the probability that just you are going to get a strawberry sucker. Well, 3 out of those 10 are going to be strawberry suckers. So now, moving on to the next event, we're going to assume that you did get a strawberry sucker. You're happy, you're excited. Well, now I'm walking over and I'm getting to Shirley. Okay, well, I've already given you a sucker, so I know that I only have 9 suckers left. And I've also already given you a strawberry sucker. So that means I've gone down 1 more on my strawberry suckers. So I only have 2 left in my hand. So my new probability for that is 2 over 9. So 3 times 2 is 6. 10 times 9 is 90. And that fraction reduces to 1 over 15 and 0.067. You could also write that as 6.7%. Okay, so that's the probability of you getting the dum-dum sucker that you want. Okay, I want you guys to try number 6 on your own. Here's what I will tell you. You have 26 candies. Okay, so 26 is going to be your total. Okay, 26 is going to be your total. There are 6 Starbursts, 10 Snickers, 10 Reese's. What is the probability that Miss Humber draws a Starburst, eats it, and then draws a Reese's? So because I'm eating a Starburst, my total is going to go down to the next round. So I want you to see if you can figure out what the numerator is on that one and what the numerator is on that one and multiply them together. Notice that one's talking about Starbursts and one's talking about Reese's. So if I eat a Starburst, that doesn't affect how many Reese's I have. That just affects the total number of candies that I have in the dish. Okay, let's take a look at deciding if some of these are going to be independent or dependent. So first of all, choosing the color and size of a pair of shoes. Does color affect shoes or affect the size? That's when you need to ask yourself, does color affect the size? No, they don't. Okay, so these two are going to be independent events. Because if I choose one color, I should still have a choice of size. Next, choosing the winner and a runner-up at a dog show. So let's say I decide who the winner is. Okay, can you be the winner and also be the runner-up? Well, no, you can't. Okay, you can't be the winner and the runner-up. So once I've chosen the winner, I have one less person I can choose for the runner-up. So the runner-up is dependent upon the winner. So that makes this a dependent event. Okay, so I'm going to have you guys go ahead and look at these last 2. And I want you to decide if they're independent or dependent. So if you're choosing a president, vice president, secretary, and treasurer of the student council, assuming that a person can only hold one position. Once I choose the president, can the president also be the secretary? Or is my secretary choice dependent on who is the president? Secondly, selecting a fiction book and a nonfiction book. If I select a fiction book, does it affect which nonfiction book I select? So that's what you need to ask yourself. Once you're done, bring up your completed note sheet to Miss Humber up front, and I will give you your homework. Thanks for listening.